So today we will learn about the flash zone pressure calculation in the vacuum distillation column. So we'll take our simple example how to calculate the pressure at the flash zone, and also we have to find out whether we need a steam or not. This is our given condition for the flash zone, and these are the calculated basically in the earlier PPT. The maximum temperature is given here 725 degrees Fahrenheit. That is important, that we require it. And then minimum tower top pressure 10 mm, that is the minimum possible pressure at the top of the column. Then these are the two decomposition gases. We have discussed about the concept of decomposition gases. Their molecular weights are given here. Air leakage, we have assumed this amount of the air leakage. Molar flow rate of LVGO, HVGO, and the overflash. Their moles are given here. These three products are basically produced from the vacuum distillation column, and the total amount of the vapor at the flash zone, that is 65.4 volume percent. So at the flash zone we need to vaporize the 65.4 volume percent of the feed, and these are the required materials. There are three products from the vacuum distillation column. So how to calculate the pressure? This is, for example, the three products, first, second and third products. Three products are there. So first we have to calculate some molar ratio and mole fractions of hydrocarbon in the flash zone. So the product that is leaving from the flash zone, that is the LVGO, HVGO and overflash. If we add all these three, we'll get the 1164.4 moles per hour. And hydrocarbon gases and vapor leaving the flash zone, if we convert their values into molecular weights, divide the molecular weights, and then we add in terms of moles per hour, that comes around 75.3. And the air leaving the flash is 1.5 volumes, because the value 44 divided by 29 molecular weight. So amount upon molecular weight gives the number of moles. So the total moles in the flash zone is 1242, out of which 1165.4 moles are the products. So we can find out the mole fraction of these hydrocarbons with the help of simple the total amount of the hydrocarbons divided by the total moles. So 1165.4 divided by 1242.2, that comes around 90.94 fractions, means 94% of our material is the hydrocarbon products that is leaving from the flash zone. Now come to the next step. This is the first step that is required here. Next is how to calculate the pressure in the flash zone. So for that thing we need a EFV curve. For the EFV curve there are three parameters. One parameter is temperature, that is given 775 degree Fahrenheit. The second parameter is amount of vaporizations. So amount of vaporization is also given, 65.4 volume percent should be vaporized from the feed at the flash zone. So these two values are given. So with the help of these two values, how we can get this is a EFV curve. X-axis, this is the x-axis. This x-axis is basically temperature value, and this y-axis is the pressure value, and we have a volume percent vaporization. So volume percent is 65. It comes around, because there is no such line of 65, so we have just draw a simple 65 line, approximate value of 65. Then 775, it comes around very close to the 800. So this is a line that is representing the 775. So at the intersection point of these two lines, we can get the value of the y-axis, that is the pressure. It comes around 30 plus, means 32, 33, like that. So we can say that in our case, temperature and the vaporization are given. With these two, we can, with the help of the EFV curve, we can get the pressure at the flash zone is 32 mmHg absolute. This is the important thing. We have to maintain the 32 mmHg absolute, that is the pressure required here. We cannot go beyond that pressure. If we increase the pressure, vaporization will be decreases, as we know it. So our next target is, this is about the calculation, that is the pressure developed in the flash zone. But what about the minimum pressure possible in the flash zone? So minimum pressure possible in the flash zone can be calculated by the top pressures, that is a pressure given at here, and that pressure is given as a 10 mmHg. It is given value. Now come, there are three products, so these are the three products. So these are the draw tray, and these draw tray are known as a chimney tray. So there are three chimney trays. For one tray there are 2 mm Hg pressure drop. So for the three tray there are 3 multiplied by 2 is equal to 6 mm Hg. This is basically the 6 mm Hg pressure drop because of the three chimney trays. Now come to the mass transfer section. This is a sections, mass transfer sections. There are three mass transfer section, that is also known as the grid sections. So and for the one mass transfer section there are 2 mm pressure drop, and for these three there are 3 multiplied by 2 is equal to 6. So 6 mm pressure drop for the grid sections, 6 mm pressure drop for the chimney, and the minimum pressure drop at the top is 10. So 10 in figure, and then we have to add all these pressure drop. That comes around 12 and plus 10, that comes around 22 mm Hg. This is the minimum pressure possible in the flash zone, but we have calculated our pressure is 32 mm Hg. That is the important thing. Now we have to come to the conclusion part, because what we need we have calculated here. Conclusion part. Minimum pressure we have calculated 22 mm Hg, means we cannot create the pressure less than 22 mm Hg. That is the condition. That pressure calculated at the flash zone by EFB curve is 32 mm Hg. What it means, that is the pressure required for the vaporization of 65 volume percent. So the pressure should be either 32 mm Hg or less than 32 mm Hg. It cannot be greater than 32 mm Hg. If the pressure is increased, then obviously the volume fraction vaporization will be decreased. So that is why we can conclude here, since the pressure, partial pressure of hydrocarbon is higher than the minimum pressure at the flash zone, therefore we don't need any bottom steam in the column. So what we need here is that the pressure, calculated pressure, should be greater than the minimum pressure required. So that is the dry, no steam required, means the dry tower operations is going on. If suppose for example the minimum pressure possible here is 50 mmHg, just take the second example. If that is happen here, not 22, it is 50, and we have calculated 32 mmHg. What it means, that we cannot maintain the 32 mmHg pressure. There are minimum pressure of 50 mmHg. So if the 50 mmHg pressure will be persist on the flash zone, obviously 65 mole percent will not be vaporized. So for that time we need to take the help of the bottom steam to vaporize the 65 mole percent. So to vaporize, the required slate steam will be added in the bottom section. So that is the basically conclusion, and we have to first find out minimum pressure, and then the EFB pressure. We have to compare it whether our bottom means whether the distillation column required steam or not, bottom steam. That's given on the pressure calculations. So this is all about calculations. Thank you very much.